Okay, cool. Everybody ready? We go for chapter 5. Okay, chapter 5. As usual, I am going to maybe touch and go every little subtopics. We'll talk about the notes as we go on. So I think we shall all turn to question number 2. Well, at the meantime, Chapter 5, okay, quite recent lah, not something very far away also. Well, the very beginning of chapter 5 is the characteristics of water lor. Well, pretty straightforward lah. Help yourself a bit. These are the characteristics of water. And down to decomposition of water, that means electrolysis. Okay, this is one of the very important experiments as well. I think we shall also try on the questions. So, okay, let's do this. First thing first, whenever we do electrolysis, you have to check out the battery. So the battery, long side, positive. So the positive side goes to anode. Okay, so anode, positive. And then negative side goes to cathode. Okay, which is negative. Yeah, well, according to your syllabus, you have to sort of memorize a bit. The anode, right, will attract the oxygen out of the water. Okay, because we know water is H2O, so there is oxygen, there's hydrogen. So the anode will sort of like attract the O, and the cathode will sort of like attract the H. Okay, but it's actually H2 and O lah, but just for illustration purposes. Okay, so we know that the oxygen goes to the anode, we know that the hydrogen goes to the cathode. Okay, like that's the, just to confirm everything. Now name the process shown in diagram above. Okay, it's called electrolysis of water. Okay, so boom, dish, there you go. Okay, so let's have the experiment carried on, and then it goes on for 10 minutes. Nothing happened. What's the problem? Okay, maybe a lot of y'all might be thinking, the switch lor, where got people turn off like that one? No, okay, we turn on the switch. Okay, the switch is touching, everything goes on already, but for 10 minutes nothing happened. That means some problem here. Do you realize what's the problem? Like, did we miss out something? Okay, let me check with you again. So the problem here is that water itself is actually not a good conductor. So I think something is missing, is because water plus something. So water should be adding on with sulfuric acid. Okay, so sulfuric acid is missing. So basically water is a poor conductor. Without sulfuric acid, right, electricity doesn't pass through. So the why there's nothing happen here is because there's no sulfuric acid. But if you're gonna write like, because sulfuric acid is not added, that's not too good, because I reckon there's like another question here, question C, actually asks you what to do. Then I think then only we say like add the acid lah. So I don't think I want to repeat the acid for 2 questions. So for here, I'm just gonna say, why nothing? But because the water also did not conduct electricity, the water did not decompose. Nothing happened. Then they ask, then how? What can we do? Then only you say, add acid lah. You'll get it right, the sequence. Sometimes you have to analyze a bit, which is better. Okay, so like for the reason, okay, like 2 marks. Number 1, water did not decompose. The water did not break down. Why? Because water is a poor electrical conductor. 2 points. Okay, and then question says, suggest a way to overcome the problem. So what should we do? Of course, we will add the acid lah. So either you write sulfuric acid or you write hydrochloric, both okay lor. So I'm just gonna follow what we used to, which is a few drops of sulfuric acid. Okay, understand maybe in school your teacher doesn't do a few drops. Your teacher might do like more drops. Can also. The more drops you add, the faster the electricity conduct, the faster the result produced. So if you don't want to wait, just add more acid, then settle, don't have to wait for too long. So be careful dangerous if you have too much acid. Next one, what's the problem, or when the problem has been overcome, describe the observation in P and Q. Okay, so first thing first, we know that individually the oxygen will go to P, the H will go to Q, right? But I think we cannot really recognize that those gases are hydrogen and oxygen, like, because question asking for observation. Can you really differentiate with your eyes, like, oh, this transparent gas must be oxygen, oh, this transparent gas must be hydrogen? Cannot ma. So it's better not to mention the names. So what you're gonna say is what you see. So what I see, 2 marks. Number one, I starting to have like, I see some bubbles coming out. So it started off with like bubbles only. Then slowly the bubbles like all goes up, right? And then it becomes like gases. So for first mark, I think we mentioned like I see gas bubbles. Then second mark, I say, then the gas are collected at P and Q. But I'm not sure what gas. I'm going to leave the gas to the next question. Okay, so sometimes you have to be aware of your marks as well. So first mark goes to, boom, gas bubbles are released. Second mark goes to, gases are collected at P and Q. Okay, like, okay, no problem. Okay, so just to remind you again, P is anode, Q is cathode, So if I know it's anode, it's going to be oxygen. But how to test? Suggest the test. Okay, like, boom, everybody. It's from here lah. The test for oxygen, hope you remind yourself a bit. That's called glowing wooden splinter, and then burning. So the difference is glowing without fire lor. Burning got fire lor. Because hydrogen is flammable ma. We put fire, then bim bam boom, magic. Your school disappear. Dangerous. If we test oxygen, we use glowing because oxygen supports combustion, then it burns again. Reignite is the keyword. Literally, we're gonna copy the whole observation the result, and then we talk about the gas. Because question is asking what test do you use and what element is what. So this is where you will mention the gas. Glowing, burning, reignite, pop sound. Those are the keywords. Okay. Right, let's go everybody. Should we do 23, 24, 25? Okay, I think we shall get to the next thing. So you're done with this, right? Let's go. Boom. After the evaporation, after the electrolysis, then we go to evaporation. I think that's very straightforward Let's probably not do this. Well, evaporation has 4 factors. Okay, humidity, surrounding temperature, movement of air, surface area. This one you learn in primary school also, so not a big deal Then followed by your solutions, rate of solubility. So we have 3 different types of solution: dilute solution, concentrated, saturated. Okay, we always fix the solvent, we always fix the liquid, but it's just that whether we add more solute or not. Okay, so when we say dilute solution, means like okay, we add little solute, so it's diluted. Concentrated is like more, saturated is like excess, like maximum now, you cannot add anymore. Okay, cool. Then we have to differentiate solution, colloid, and suspension. So long story short, because this is gonna take like the entire session, remember back then. But let me just give you like important points to help you differentiate instantly. First of all, the appearance is very important. If you have a cup of water or a sugar solution or salt solution, and you have a cup of milk, and you have a cup of muddy water or sandy water the appearance makes a lot of difference. Number one, if it's transparent and clear, allow light to pass through, there has to be solution. The reason we call it solution because number one, it is transparent. Number two, the particles are so small that your eyes cannot see. That's why it's transparent. Okay, it dissolves properly or completely. But for colloid, colloid is not transparent, and the light doesn't pass through, and there is no particles sinking to the bottom or floating at the top. It's just the whole thing is just one uniform liquid. Okay, so it's not as clear as these, but it's like in between. Yeah, because the third one has to be the dirtiest water, or I can say that it's not uniform in color, maybe darker at the bottom, lighter at the top. There is something sinking, there's something floating, light doesn't pass through, the particles are so big that it just floats and sink, doesn't dissolve completely. Okay, cool. So I think colloid is like in between, no? If you say like, is it as clean as like clear water or like distilled water or such a salt solution or sugar solution? No, it's not as clear, but it's not as dirty as this one. Okay, that will be the shortcut because there's a lot of things to digest here also. Okay, along the way we come back if we need to. Jom, write true or false for the statement below. Okay, so colloid consists of one solute only. Wait, what? Colloid consists of one solute. Where's that such rule? I don't think there's such rule, right? Even for solution and suspension, you can add more than one thing, right? Colloid is one meh? No, it's two or more solute. Okay, so that's a false statement. Bam. Okay, next. Particles of colloid cannot be separated by filtration. Think about this. You have a cup of milk. You have a cup of milk, and you try to use filter paper to filter the cup of milk. Can you filter anything out of the milk? If you have not tried it, then let me tell you, it's not. Or you have tried it before. You can imagine milk has nothing floating or nothing sinking at the bottom, right? There's no residue, basically. So you cannot separate milk component by using filtration. Okay, so cannot be separated by filtration. That's true statement. Bam. Okay, okay, like mark C for the examples of colloid in daily life. Ooh, colloid. Okay, speaking about juices, a bit like there's argument to this also lah. So usually when we say fresh juice, you know, like when you go to restaurant and you order like fresh orange juice or apple juice, that is suspension because there's things floating inside, there's things sinking at the bottom, there's things around it, right? So that's pretty much suspension. But if you all buy like the beverage packaging, you all drink before, right? Those thick oranges, those flavored juice, it's actually transparent one. You all buy before, right? Like apple juice is a bit like tea color, like brownish, yellowish, right? But it's transparent and there's nothing inside floating or sinking. So food like packaging one or like those fake juices, flavored juice, those could be solution. Okay, those be solution. But the fresh juice is actually suspension. Okay, can? Okay, like Coca-Cola. What do you think? Look at the appearance. I mean, imagine the appearance. Coca-Cola, you all pour before into like transparent glass or not? Then that's a lot obvious. I think there's nothing floating inside. I mean, apart from the air bubbles, there's nothing floating. There's nothing sinking. It's clear. It is, although darker in color, but you know, it's transparent almost without the color. Okay, so that should be solution as well. Okay, yeah, okay. So shaving cream, the whole cream is white color, uniform in color. Is it transparent? Not really. Can light pass through? Not really. If you try to filter the cream, the shaving cream or whipping cream, I don't think there's anything will be on the filter paper, right? So that should be colloid. So that's how you differentiate, basically. Ice cream is almost the same idea. It's uniform in color, If you try to filter ice cream, basically everything just go through the filter paper, and light doesn't pass through. There's nothing sinking or floating like suspension, so that should be colloid as well. 2 marks. Okay. Ding. Right. What else? Examples that textbook give you. I remember textbook gives you mayonnaise. Mayonnaise is actually under colloid as well. Okay. Like cream or sauces like ketchup. Those are also colloid as well. Okay. Good. Okay. So let's see what do we have for the next one. Right. This is to separate the three things into different characteristics. Okay. We have some given, but I think you need to look out for G, L, K, H, J, and I. Okay. I hope this question could actually help you to like understand better the whole thing. Okay. So you all know this Venn graph, right? This is called a Venn diagram. So the circle alone is the characteristics, but if there is any cross area like this, that should be sharing the same characteristics. Okay, right? So for example, solution for G, that means only special to solution. Your choices are here to choose. Okay, now we could go one by one to do the kick out method lah. Then it's a lot easier. Okay, so solution characteristics only. What do we have? If you do one by one, number one, can solution be separated by filter paper? Like, can you filter salt water? Like, can you filter the salt out of the water? I don't think so, right? So, bang, bang, out. Okay, does not scatter light. The meaning scattered means like reflect, scattered. So you see the sky has a lot of particles in the atmosphere. Those particles scattered the light. It's sort of like showing and reflecting the light to your eyes. Okay, so if you shine your torchlight through the solution, does the solution reflects the light to you, or the solution allows the light to pass through? Like, try to use torchlight to shine through your mineral water. Light goes through, right? That means does not scatter. So scatter is like bouncing off or reflecting to you. Okay, so boom, there you go. Does not scatter light, belongs to solution. Because colloid will scatter like a cup of milk, right, will bounce all the light away. A cup of muddy water, right, will bounce all the light away. But a cup of salt water doesn't bounce the light away. So does not bounce the light away. Okay, right, next one. H is between solution and colloid. The similarity between solution and colloid, this one out liao lor. Large particle, I don't think so. That's for suspension, the sand and the muddy water. Scattered light, no, just now already say not scattered for solution. Medium size, no, medium size is colloid because solution is very small. Pass through filter paper. Can salt water pass through filter paper? Yes. Can milk pass through filter paper? Yes, correct. Boom, pass through filter paper. Okay, noise. Okay, I is only special to colloid. Colloid is scattered. Suspension also scattered light, so I think that could be J though, but now I think only to colloid is medium size. Boom. Yeah, there you go, medium size. Okay. Alright, J, I think we kind of had the hint just now. A cup of milk and a cup of muddy water bounce the light away. Okay, bounce the light away. Boom, scattered light. Okay, then the last two doesn't matter liao because they are in the same circle for suspension. So suspension has large particles, correct, so big that they cannot dissolve completely and you can see with your eyes. That's why it's floating or sinking to the bottom. Number two, yes, suspension or sandy or muddy water can be filtered away. Okay, boom. There you go. The last two. Sequence doesn't matter lah. Huh? Okay, no problem. Okay, like B. Very simple. We all will give examples. So just try to remember a few that will always be the same. So then you in your exam you stick to that few answers, then you are safe. So solution, anything that is transparent or like salt water, sugar water, you know, up to you. Suspension. Suspension must be things that cannot dissolve properly, like sandy water, muddy water, fresh orange juice. Yeah. And then colloid should be anything in between, but I told you the best answer is always your milk. Mayonnaise. Yeah, those are good answers. Okay. It's not as clear as like like solution, but it's not as cloudy and dirty as suspension. So milk is like in between. Okay, cool. Water as universal solvent and organic solvent. Two things we need to talk about. So water as universal solvent. So we talk about universal solvent means water, and the opposite is called organic solvent. So universal solvent basically means the very famous water that can probably dissolve everything. Okay, like even your body needs water to dissolve and digest food, this and that, right? Washing clothes, cooking, bathing, cleaning the house, all these you need water to dissolve things, dissolve the dirty things or the detergent and whatnot. Okay. The other opposite is called organic solvent. Organic solvent means the rest that does not dissolve into water, insoluble with water. So for example, right, like oil doesn't dissolve in water. Then how? Then nothing else on earth can dissolve. So things that doesn't go to water, right, can go to organic solvent. So alcohol can actually dissolve oil. Okay. So alcohol will be like, hey, oil. I heard that you're not too happy with water, right? And that's why water doesn't want to make friends with you. You know what? Never mind. I'm always here for you. I'm your friend. My name is alcohol. You can come to me and talk to me, although water doesn't want to talk to you. Okay. So organic solvent are solvent that tries to dissolve solute that doesn't dissolve in water. So this is the annoying part lah. You have quite a lot of solvent and solute to try to remember. But if you ask me, I would say the first three is like the minimum that you must know from your textbook. Alcohol, turpentine, and acetone. These are like almost very famous examples that they will ask. So alcohol basically is everything though, like they can dissolve almost all colorings, iodine, perfumes, paint. Turpentine is especially for paint. Yeah. Acetones are for like nail polish and makeup stuff, like nail polish remover for girls. If you do your nail polish, or your mom or your sister, they have acetone to remove the nail polish. Okay. Yeah, so that's pretty much to separate water and organic solvent. So water is like the famous person the famous person in your school everyone like, whoa, water, we handsome, we good looking, we pretty. Everyone knows water. But I'm pretty sure some in the school doesn't like the particular person where everyone likes. You know, the famous girl, the famous boy in your school. Maybe there is some hater lah. Not everyone like you like the haters are called organic solvent. You can go for the other way. Okay, so let's see what do we have. Number one, draw lines. Turpentine for what? GG. Okay, need to memorize a bit. Turpentine is actually for paints. Let's see. Boom. There you go. Paint. Okay. Can okay. Acetone for what? Acetone for nail polish. Yep. Nail polish stuff. So, boom. Acetone. Okay. Makeup remover. Like that lor. Well, it's not going to be very difficult on your subjective, but maybe like the section B where you have like circle, underline, draw lines, fill in the blank, that kind of question. Yeah. Okay. So, jom, line. B. Fill in the blank to complete the statement below. Water is used by aquatic organisms to dissolve oxygen and something for their life processes. Well, aquatic organism includes animal and water plant though, like seaweed and the rest. So what gas do we have? Yes, oxygen for animal. What for the plant? Obvious enough, right? Yes, correct. Carbon dioxide. See, water is so important. Without water, the fish cannot breathe air. The plants cannot take carbon dioxide. Okay, water is a very famous solvent for many things. In a cleaning process, water is used to dissolve. So when you want to mop your floor, you want to clean your toilet, you need to use water to dissolve detergent, like your washing stuff. So your detergent cannot just use by itself. Like, can you just pour your detergent on the floor and try to mop your whole floor? I think not too appropriate lah. Of course, we need water, the help of water. See, water so famous. Some more got what? So many things in your textbook here, like drinks, detergent, cleaning agent, cooking, fertilizers. See, without fertilizers, without water, fertilizers cannot be absorbed by the roots because you need to dissolve in the water. Okay, medicine uses water to dissolve. Okay, jom, right? What organic solvent can remove chlorophyll? Coloring, water cannot remove one. For example, if you kena ink on your white shirt, pen ink lah, marker ink, whatever ink, wash water very difficult one. See, those are that water doesn't want. No. Hey, I don't know you lah, you coloring, who are you? So, okay the water don't want me, right? She thinks she very famous. He thinks he very famous, right? Don't want to say hello with me, right? I know there's another type of solvent that I can look for, which is called organic solvent, right? So any solvent that can remove color, okay, this one is I would say the best organic solvent of all that tries to dissolve a lot of things, which is alcohol. Okay, alcohol is quite a famous it's a famous organic solvent as well. Okay, so yeah, coloring can use alcohol. If you kena ink on your white shirt or soft, if you don't have like pure alcohol, use like the sanitizer, can help a bit. Or any alcohol swab also can. Okay, yeah, correct. Okay, figure below shows 4 t-shirts with different stain. Mark on the shirt with the stain. Okay, mark on the shirt with the stain that cannot be removed with alcohol. That means alcohol cannot remove one. Alcohol also cannot remove one. First of all, can alcohol remove paint? Yes, you can. Alcohol can remove colorings and paint. Can alcohol remove or dissolve iodine? Yes. The first thing, okay, is to dissolve iodine to make your yellow medicine for your wound. If you cut yourself or you fall down, you want to wipe on your wound. So that's called iodine. So yes. Can alcohol dissolve shellac? Shellac, what is that though? Shellac is like varnishes, or the layer where you apply to the wood and make it shiny. Shellac, to make the wood shiny. So that's called shellac. That one alcohol also can dissolve, because do you all realize that kind of thing smells like alcohol, the chemical smell, because those are the base, the solvent to dissolve. So yes. Okay. Starch here doesn't mean like rice, bread, pasta. What do you mean like rice kena your shirt? Got stain one meh? Okay, usually when we say starch stain, it actually means sauces. Ketchup, tomato sauce, that kind of sauces, like mustard sauce. Sauces are usually starch based. Or baby food, the baby digestive food, like it's like almost like glue like that. Newborn baby food, that kind of starch food, starch paste, that one can actually stain your shirt. So alcohol cannot remove starch. Okay? Yeah, so starch you need to use like soap lah or whatever you wash your clothes. But others you use soap cannot one. You need alcohol to help. Okay? Hey, there you go. Okay, out of order, no problem. Good. Cool. Let's move on to the next question, shall we? After this topic, then the next will be water purification method. Okay, the one that you have to memorize the steps that the water goes to your house. Okay, so water purification method, right, includes of filtration, boiling, chlorination, and distillation. Okay, so filtration means filter the suspended particles, the big things. Boiling is to kill microorganisms. Chlorination also to kill microorganisms, but in a larger situation like pool, swimming pool, water treatment plants. Distillation is the best to remove everything. Okay, so then you go down to the sequence to memorize this. So let's try out the work and see how it goes. Okay, so sometimes in exam they will not give you the whole sequence. I mean the whole sequence is quite long though. Obviously this picture something's missing lah. Okay, so I think the first one is already not the first one. Question asking you to name the tanks below. PQRs. Okay, the first one in your textbook it is filtration tank, but look at that, I don't think that's filtration though. There's like two things you add into the tank. So like you refer any tank that has two things going in the tank. There you go. Correct now. Slick line. That's the first tank where you have two things added in. Wow, the question start off with coagulation. Okay, coagulation. You start with coagulation. Okay, but because question doesn't always give you everything, remember that they will just skip a bit. Okay, so next one, Q. After coagulation, it should be, you follow on and the picture shows you something settled at the bottom. So should be sedimentation. Yeah, boom, sedimentation. Okay. R, a lot of layers though. Layers after sedimentation. Layers. Filtration again. That's a lot of layers of sand to filter away the dirty things. So filtration tank. Okay. Why suddenly skip to consumer? The last tank to consumer. Consumer, your house. So the last tank is called storage tank. Okay, and so there you go, storage tank. Well, since we're here, right, let's also write the tank for this one. There's one more tank that you add two things into it. Let's check out the answer. This one, chlorination and fluoridation. This is a tank where you add two things into it. Okay, so did the question ask about it? Not the name though. So let's write chlorination and fluoridation. Chlorination, fluoridation tank. Okay, which is also the next question actually, asking for chemical L and M. So what did we add though? The answer is here. Free answer. So what do we add? We add chlorine and we add, let me just check the whole thing again. We add chlorine and we add sodium fluoride. It's not just fluoridation. Fluoride is sodium fluoride. So chlorine, fluoride. And the function is here though. I think that's the next question. Okay, so chemical L, no sequence doesn't matter I start with chlorine and then I go for function. Straightforward, right? Okay, no problem. To kill microorganisms. Okay, M should be sodium fluoride. And what's the function? That's to prevent tooth decay. You can copy exactly with that. Tooth decay. Okay, next one. Where is tank S situated? With tank S means the last one, storage tank. Okay, we don't have this in textbook, but near your taman, you should have one big water tank for everyone. Do you all realize where is the water tank? And where the situation is? It's not like not really asking for location though. How should I explain this? It's actually asking. It's asking for the height. If you realize, right, all these tanks have to place at very high places, like at least taller than your taman or your town. Okay, so usually water tank needs a lot of water pressure. So if you put it too close to the surface or like near to where your house is, the water pressure show not enough to push all the water to every house. So it has to be built at somewhere very high, tall places, high locations. That's actually what question is asking. Okay, usually situated on high place. Sometimes you see it beside the highway sometimes, but it's a very tall tower, water tower. Okay, right. D, suggest 4 ways to conserve water. These are like sort of methods that you should like practice daily one, like to save water and stuff. So I know water is very cheap for Selangor people, okay, because the government subsidized, so pretty much your water is free, or like you pay very little even though you free flow your water. Okay, you actually have a water park behind your house, but still conserving water is very important. Now what should we do? Like normal things that your parents should tell you, like turn off the tap when not in use, something like that. Okay, or like even wash the vegetables in the basin, not running water. I'm guilty as well. Like when I wash vegetables and fruit, I just run the water. But the correct method is to wash in the basin. So yeah, okay, things like that. So what else? Turn off tap when not in use. Yeah, there's this function, guys. You can actually turn off your tap when not in use. Or when you brush your teeth, just let it run. Or do you turn it off and you brush, and then when you're done you turn it on again. Okay, what else? Like fix leaking tap. Don't underestimate the water though. Leaking tap could probably leak out like a swimming pool at the end of the day, because like every second one drip. After a whole day, there's a lot of water. What else? Like use the water that you wash the vegetables to actually water the plants, or the water that you wash the rice to water the plants, things like that. Okay, no problem. Cool beans. I think that's it we need to do today. Peace. Take care, everybody.